Hello friends, welcome to the channel. In this video, we'll solve KSET 2016 Physical Science Paper 2, first 25 questions. If A is equal to 2i plus 2j plus k, A dot B is equal to 14 and A cross B is equal to 3i plus j minus 8k, then B is equal to. So given that A is 2i plus 2j plus k. So if you consider B as B1i plus B2j plus B3k, then A dot B can be written as 2B1 plus 2B2 plus B3, because A dot B is A1B1 plus A2B2 plus A3B3. And here it is given that value is 14. Then A cross B means I, J, K. Then A1 is 2, A2 is 2, A3 is 1. So B1, B2, B3. So from the option one can see that, so value of B1 is 5, B2 they have given it as plus or minus 1, and value of B3 plus or minus 2. From this, so B1 is fixed here, B1 is 5, so 10 plus 2B2 plus B3 is equal to 14, means 2B2 plus B3 is equal to 4. Now this holds good for the value B2 is equal to 1 and B3 is equal to 2. 2 into 1, 2 plus 2 is equal to 4. Therefore, value of B1 is 1 and B3 is 2. Therefore, vector B is 5i plus j plus 2k. Option C is correct. The vector that is perpendicular to the surface x square plus 2y square plus 3z square is equal to 4 at 0, 1, 1 is, so vector, so that is perpendicular to the surface at 0, 1, 1. So if this is tangent, we have to find perpendicular to the surface at 0, 1, 1. It is given by del phi. It is I dou by dou x plus j dou by dou y plus k dou by dou z pi. It is pi is, so here pi is x square plus 2y square plus 3z square minus 4. 3z square minus 4. So I dou by dou x of x square plus 2y square plus 3z square minus 4 is 2x plus j dou by dou y is, so 2 into 2y, 4y plus k, it is 6z. Therefore, vector that is perpendicular to surface is 2xi plus 4yj plus 6z k at 0, 1, 1. So x value 0, y is 1, z is again 1, 4j plus 6k is the answer. A body is executing circular motion about the point O134 with a radius of 5 units. The direction of the acceleration of the body when it is located at 100 is given by the vector. Here, given that body is executing circular motion about a point O134 with a radius of 5 units, and this you can consider as position vector r. Then we have to find acceleration of the body. So here, for circular motion, velocity is always acting as a tangent and acceleration is towards the center. Acceleration is towards the center, but it is opposite to position vector, direction of position vector. Therefore, here we have to find direction of acceleration at 100. So acceleration is given by x1 minus x2 I plus y1 minus y2 j plus z1 minus z2 k. If you consider this as x1, y1, z1, this one as x2, y2 and z2. x1 minus x2 is 1 minus 1 I plus y1 minus y2, 3 minus 0 j plus 4 minus 0 k, that is 3j plus 4k. Therefore, direction of acceleration of the body is given by 3j plus 4k. The eigenvalues of the matrix 0 minus I 0 are. So matrix A is 0 minus I 0. We know that sum of eigenvalues is equal to trace of matrix A. Trace means sum of the principal diagonal elements. So trace of principal diagonal element, trace of matrix A or sum of principal diagonal elements is nothing but sum of the eigenvalues, and then product of eigenvalues is given by determinant A. From first point we can say that sum of eigenvalues is equal to 0. So it is possible only for two options, for A and D. Then we have to find eigenvalues. How to find eigenvalues? So we have to write determinant A minus lambda I is equal to 0, where I is identity matrix 1 0 0 1. So A minus lambda I is minus lambda minus I minus lambda is equal to 0. It is lambda square minus I square is equal to 0. Lambda square minus plus I square is minus 1 is equal to 0. Therefore lambda square is equal to 1, which implies lambda values are plus or minus 1. Therefore eigenvalues of the matrix is 1 and minus 1. Next question is the eigenvalues of the matrix 1 0 0 0 1 1 0 1 1 are. As we discussed, trace of matrix is sum of the eigenvalues. So here sum of the eigenvalues is given by trace. Trace is sum of the principal diagonal elements, that is 3. So sum of the eigenvalues is equal to 3. That is possible only for option B. 0 plus 1 plus 2 is equal to 3. Therefore, option B is correct answer. This general solution of d square y by dx square plus omega square y is equal to 0 is. Consider d by dx as capital D, then d square y plus omega square y is equal to 0. Y is common, is equal to 0. That implies d square plus omega square is equal to 0. That means d square is equal to minus omega square. Therefore, value of d is plus or minus omega I. Now we have to find the roots of this equation. Then we have to find general solution of this differential equation. If roots are alpha and beta and they are distinct, the solution will be y is equal to c1 e raised to alpha x plus c2 e raised to beta x. So if the roots are, second case is if the roots are repeating, this is for repeating roots, and y can be written as y is equal to c1x plus c2 e raised to alpha x plus c3 e raised to beta x. So here in all cases c1, c2, c3 are constants. Third case is if roots are imaginary, that is roots are in the form alpha plus or minus I beta, then y is equal to e raised to alpha x. So c1 cos beta x plus c2 sin beta x is the solution. Here in this case d is imaginary, so roots are imaginary, therefore solution is e raised to 0 because it is in the form alpha plus or minus I beta. Value of alpha is 0, e raised to 0 c1 cos omega x plus c2 sin omega x. So instead of c1 c2 we can write c and d, capital C and D, c cos omega x plus d sin omega x is the answer. If f1 is equal to 2x plus 2iy and f2 is equal to x square minus y square plus 2ixy, then choose the correct answer. Options are f1 is not analytic, f2 is analytic, f1 is analytic, f2 is not analytic, f1 and f2 both are analytic, both f1 and f2 are not analytic. As we know, a function f is equal to u plus iv is said to be analytic function if two conditions are satisfied, that is dou u by dou x should be is equal to dou v by dou y. Second condition is dou u by dou y should be minus dou v by dou x. Let us check this for functions f1 and f2. So here in f1 u is 2x, v is 2y, then dou u by dou x is equal to 2, dou v by dou y is equal to 2. So dou v by dou x is equal to dou v by dou y. First condition satisfies here. Then second one, dou u by dou y. So differentiation of u with respect to y, partial differentiation of u with respect to y is 0. Then dou v by dou x is again it is 0. Dou u by dou y is equal to dou v by dou x. So both are is equal to 0. Therefore, second condition also satisfies here. Therefore, we can say that function f1, this one is analytic. Now, check it for f2. f2 is x square minus y square plus 2y xy. Here u is x square minus y square and v is 2xy. Now consider dou u by dou x. Value is 2x, then dou v by dou y is also equal to 2x. That means dou u by dou x is equal to dou v by dou y. Therefore, first condition satisfies. Now consider dou u by dou y. So partial differentiation of u with respect to y is minus 2y. Then dou v by dou x is 2y. So from this we can say that dou u by dou y is equal to minus of dou v by dou x. So second condition also satisfies here. Therefore, function f2 is also analytic. Therefore, option C is correct. f1 and f2 both are analytic functions. The value of integral I is equal to 0 to 2 pi d theta divided by 5 plus 4 cos theta square is. Some standard integrals are value of integral 0 to pi d theta divided by a plus b cos theta is given by pi divided by square root of a square plus b square. Similarly, 0 to 2 pi b cos theta is given by 2 pi square root of a square plus b square. Then 0 to pi d theta divided by a plus b cos theta whole square is given by a into pi divided by square root of a square minus b square raised to 3 by 2. Integral 0 to 2 pi d theta divided by a plus b cos theta square is 2a pi divided by a square minus b square raised to 3 by 2. So question is in this form. Therefore, 0 to 2 pi d theta divided by 5 plus 4 cos theta whole square is equal to 2 into a. Here a is 5 divided by a square, 5 square is 25 minus b square means 4 square, 60 raised to 3 by 2. That is 10 pi divided by 25 minus 16, 9 raised to 3 by 2. That is 10 pi divided by 9 means it is 3 square raised to 3 by 2. 2 and 2 cancels. 3 cube is 27. Option B is correct. A bag contains 6 red balls and 4 blue balls. The probability of drawing 2 red balls in succession is. So given that there are 6 red balls plus 4 blue balls. That means in total there are 10 balls. Therefore, probability of taking 2 red balls in succession is given by 6c2 divided by 10c2. We are taking 2 balls from 6c2. In total there are 10 balls. It is given by 6p2 divided by 2 factorial 10p2 divided by 2 factorial, that is 6 into 5, this and this cancels, 10 into 9, 5 2 is a 3 is a 3 3 is a, means 1 by 3. Option A is correct. An object dropped from sky follows the motion x is equal to half gt square. Then the acceleration of the body, given that x is equal to half gt square, then we have to find acceleration. Acceleration is nothing but d square x by dt square. So here differentiate x with respect to t. So dx by dt is equal to half g into 2t, that is equal to gt. Then differentiate it again with respect to time, then differentiation of this is g, that means it is a constant. Therefore acceleration of the body remains constant. Option B is correct. The Lagrangian for a particle of mass m in an electromagnetic field is given by L is equal to m by 2 x dot square plus y dot square plus z dot square minus q5, that is dependent on x, y, z and t, plus qa, that is dependent on x, y, z, t, dot v, the momentum conjugate to x is. So here Lagrangian is given by m by 2 x dot square plus y dot square plus z dot square minus q5. It is a scalar potential that is dependent on x, y, z and time t, plus q a is a vector potential that is dependent on x, y, z as well as t, dot velocity v. Now we have to find momentum conjugate to x. Momentum conjugate is given by conjugate to x is given by px is equal to dou L by dou x dot. So in general momentum conjugate for coordinate q is given by dou L by dou q dot. This is important, and this Lagrangian is also important. Then we have to find momentum conjugate with respect to conjugate to x. Px is dou L by dou x dot, that is m by 2 into 2x dot. Then differentiation of this with respect to x dot, since it is independent of x dot, so differentiation of this with respect to x dot is 0, plus if you consider this one here q a x y z t dot v, here v is dependent on x dot, therefore so differentiation of this part is q into a. Since momentum conjugate to x is asked, we can write it as mx dot plus q ax. Option C is correct. The Lagrangian equation of motion for a simple pendulum is, so to consider simple pendulum, consider this as theta, this one as length of the pendulum, then this coordinate will be L sin theta, and if we fix this as origin, then this coordinate will be minus L into cos theta, then V or V square is given by x dot square plus y dot square. So x dot is x is L sin theta, y is minus L cos theta. X dot square, x dot is differentiation of L sin theta with respect to time, is given by where x dot is L cos theta into theta dot, y dot is L differentiation of cos theta is minus sin theta, minus into minus plus L sin theta into theta dot. Therefore, v square is x dot square plus y dot square, that is L square cos square theta, theta dot square plus L square sin square theta into theta dot square. So L square theta dot square is common, then cos square theta plus sin square theta is equal to 1. Therefore, v square is L square theta dot square. Then kinetic energy is given by half mv square, that is equal to m by 2 L square theta dot square. And potential energy, kinetic energy T, potential energy B is given by m into g into h. H is the height, so height here is minus L cos theta, minus mg L cos theta. Then Lagrangian is T minus V, or it is m by 2 L square theta dot square minus of minus mgl cos theta is plus mgl cos theta. Then equation of motion is given by d by dt dou L by dou theta dot minus dou L by dou theta is equal to 0, which implies d by dt of dou L by dou theta. Dou L by dou theta is, sorry, dou L by dou theta dot is m by 2 L square 2 theta dot. 2 cancels, it is ml square theta dot. It is d by dt of ml square theta dot minus dou L by dou theta is mgl differentiation of cos theta with respect to d theta is minus sin theta. So minus mgl sin theta. So that is ml square d by dt of theta dot is theta double dot plus mgl sin theta is equal to 0. So m and l are common. ml l theta double dot plus g sin theta is equal to 0, which implies L theta double dot plus g sin theta is equal to 0. It is theta double dot is minus g upon L sin theta. So here option is the answer. Theta double dot is equal to minus g upon E. Instead of L, it is given as dE into sin theta. Option A is correct. Let E and P be the energy and momentum of a relativistic particle with rest mass m. Then, so direct question, and we can say that E square is equal to P square C square plus m square C raised to 4. Rotation of a vector in xy plane about the z-axis is represented by a 2 by 2 rotation matrix. What is the trace of that matrix? If you consider a xy plane, rotation of a vector in a xy plane about z-axis, that means z is constant. So about z-axis, if you rotate the vector in xy plane, then rotation matrix is given by cos theta minus sin theta 0, sin theta cos theta 0, then 0 0 1. It is the rotation matrix about z axis. If it is about x axis, then rx theta is given by 1 0 0. It is cos theta minus sin theta cos theta. Since it is about x axis, so x component, this should be 1. Then if it is about y axis, then ry theta, rotation matrix about y axis, is given by 0 cos theta sin theta minus sin theta cos theta. All these are very important. So these are the 3 by 3 rotation matrix. Now in question it is asked to find 2 by 2 rotation matrix. It is given by rz theta is equal to only this part. It is cos theta minus sin theta cos theta, and trace of the matrix. Trace of this matrix means trace of rz theta is nothing but sum of principal diagonal element, that is 2 cos theta. Therefore option D is correct. If the orbit of a body is given in polar coordinates as r theta is equal to constant, it is under the influence of a force that varies as. Given that r theta is a constant, then equation of orbit is given by u plus d square u by d theta square is equal to minus f of r m, that is mass, into L square, angular momentum square, into u square, where u is nothing but 1 upon r. So this is the important equation. Here u is nothing but 1 upon r, can be written as 1 upon r is theta upon k. Therefore theta upon k, then d square u by d theta square, du by d theta, du by d theta, so that is 1 upon k. So d by d theta of constant is 0. Therefore theta by k is equal to minus f of r m L square u square. Therefore force f of r is given by minus m L square u square upon k into theta. You know that u square is 1 upon r square. 1 upon r square. Then here theta is nothing but theta is k upon r. K cancels, minus m L square divided by r cube. Therefore force varies as 1 upon r cube. Here in this question 2 frames are given. One is S frame, which is at rest. So another one is S prime frame, that is moving with velocity u0 and acceleration a0. Then we have to find velocity v prime and acceleration a prime of a body in s prime. That will be related to velocity v and acceleration a in frame s. You know that x prime, so any coordinate in s prime frame can be represented as x minus coordinate in with respect to s frame minus u naught t. Now differentiate this equation. Dx prime upon dt equal to dx upon dt minus d by dt of u naught t. Here u naught is also varying with time because a naught is already given. Therefore, so v prime is equal to v minus, so differentiation of u naught t. U naught into d by dt of t is 1 plus t into d u naught by dt, that is v minus u naught plus here du naught by dt is nothing but a naught t. Here therefore v prime is v minus u naught minus a naught t. This is 1. Then we know that v naught can be written as u naught plus a naught t because v is nothing but u plus at. Therefore v minus v naught. Now differentiate this equation. dv prime upon dt is equal to dv by dt minus dv naught by dt, which implies a prime is equal to a minus a naught. Therefore option B is correct. The Lagrangian for a relativistic particle of rest mass m0 can be represented as, so it can be represented as L is equal to minus m0 c square into square root of 1 minus v square upon c square. Option B is correct. The electric field of an electromagnetic wave in vacuum is given by Ex is equal to 0, Ey is equal to 40 cos 2 pi into 10 raised to 10 t minus 5 pi by 3 x. Ez is equal to 0. The direction of magnetic field is, here Ey is given, that is in the form a cos omega t minus k x. So that means that the y component of electric vector is propagating, so direction of k is about z x axis, therefore it is propagating about x axis. You know that if you consider an electromagnetic field, electromagnetic wave, this is E, then magnetic field vector will be perpendicular to this wave, will be in a direction perpendicular to this E, and propagation vector, that is direction of propagation of E and B, will be perpendicular to both E as well as B. Therefore here given that propagation vector is about x axis, then E is about y axis, therefore direction of B will be perpendicular to both x axis as well as y axis, that is about z axis. Therefore direction of magnetic field is in z direction. The potential energy U of an electric dipole with dipole moment P placed in an electric field E is given by. So direct question, it can be written as U is equal to minus P dot E. The Poisson's equation for electrostatic potential phi is given as the divergence del dot E is given by rho upon epsilon. This is from Maxwell's equations, and we know that E can be expressed as scalar potential phi given by minus gradient phi. Substitute here, so del dot minus del phi is equal to rho upon epsilon, that is del square phi is equal to rho upon epsilon naught. For del square phi is equal to minus rho upon epsilon naught. This is the Poisson's equation. Option D is correct. For a uniformly charged cylinder with charge per unit length lambda of diameter 2a and of infinite length, the electric field at a point P at a distance d greater than a from the axis of cylinder is given by. Here consider a cylinder having charge per unit length lambda and diameter 2a. That means from the axis radius will be r, that is a. Given that it is of infinite length, so it is of infinite length. Now we have to find electric field at a point P, that is at a distance d, which is always greater than a from the axis of cylinder. If you consider one Gaussian surface that is in the shape of cylinder with radius d, according to Gauss law, surface integral E ds is equal to charge enclosed divided by epsilon naught. Here E integral ds means surface area of cylinder with radius. If you consider radius as a, area will be 2 pi d into L, 2 pi dl. Q enclosed is always given by lambda into, so it is nothing but charge per unit length. Therefore lambda is nothing but charge per unit length. Therefore Q enclosed is lambda into L, divided by epsilon naught. Here L and L cancels. E is given by lambda upon 2 pi epsilon naught d. Therefore option B is correct. For an arbitrary volume V enclosed in a surface S with volume charge distribution rho, the following is true. You know that del dot E is equal to rho upon epsilon naught. Therefore del dot E minus rho upon epsilon naught is equal to 0. Option A is correct. The electrostatic field at a distance r from the center of uniformly charged sphere of radius r varies as for r less than or equal to r. Here we know that for solid sphere, electric field outside the sphere can be given by kq upon r square. So here consider radius as r, kq upon r square, where r is greater than capital R. On the surface it is given by kq upon r will be is equal to radius r square. Then inside the surface it is given by KQ R upon R cube. These are for solid spheres. R is equal to R. R is less than radius. So for hollow sphere, outside electric field outside the surface is given by Q upon R square, same as that of solid sphere. Then on the surface it is given by KQ upon R square, but inside it is 0 because no charge inside, because it is a hollow sphere, therefore it is 0 inside. Here in question it is asked that if R less than or equal to R, then how it varies. And it varies as E in directly proportional to R. Option C is correct. Next question. A square loop of side A is rotated with the angular velocity omega. So it is a square loop of side A which is rotated about this axis perpendicular to direction of uniform magnetic field. So B0, perpendicular to B0, it is rotating with angular velocity omega. The EMF generated in the loop is, now you have to find EMF generated in the loop. So EMF generated nothing but minus d pi by dt, rate of change of flux, given by d by dt of A B cos theta. A is the area, B is the magnetic field, and here theta is the angle of rotation. That is minus d by dt so area of a square loop. So area of square is given by A square. Here magnetic field is B0. So this can be written as cos omega t. That is B0 A square d by dt of cos omega t is omega minus sin omega t, minus minus plus sin omega t. Therefore, option D is correct. For a uniform magnetic field B, the vector potential A is given by, vector potential A is always given by half B cross R. So that is vector potential. Similarly, scalar potential is given as minus E dot R. So always a cross product for vector potential and dot product for scalar potential. Remember these points. Therefore, here answer is half B cross R.
Thanks for watching. Hope you like this video. Kindly subscribe and share this video and keep watching.